Hello everyone. In this course, I will give you an introduction to SuperMap icon for JavaScript. I divide the contents of this course into two parts. In the first part, I will introduce the architecture of the new icon for JavaScript product. For the second part, I will explain to you how to select the correct product from the entire iClient for JavaScript package that contains 4 products for different development models. Well, first, let's look at the first part, the overall introduction of SuperMap iClient for JavaScript. It's a toolkit offered for client GIS application development with iServer package. It can be used to obtain various resources, including the services offered by iServer, iPortal, and iExpress as well. What's more, the resources of GIS services provided by SuperMap iManager, as well as public cloud online services offered by SuperMap, can also be integrated with iClient for JavaScript. Employing a blended new architecture, iClient for JavaScript integrates the leading open-source map libraries and visualization libraries. The code of iClient for JavaScript, which is fully open source and can be found GitHub and OSTrainer. It's based on the new open source architecture of Apache License version 2. It employs a brand new architecture and provides interfaces for iClient for Mapbox package and classic JS library used together with AV iServer services. You may want to know what the basic core library of these products is integrated with and what is used for. We can look at the OpenLayers products is integrated with OpenLayers 3 and 4 versions, and the display effects for such HTML5 and vector tile layers are extremely good. Based on the Leaflet product library, iClient for Leaflet is a lightweight and portable mobile development library. The practical jar. Online map services provided by Mapbox are vector tile map services, which are rendered and the client side for presentation and map style set is more convenient compared to the traditional map tile services. For visualization, these 3 effects are preferable for thematic map presentation. D3JS is a JavaScript library for manipulating documents based on data. D3 helps you bring data to life using HTML, SVG, and CSS. D3's emphasis on web standards gives you the full capability of modern browsers without tying yourself to a proprietary framework, combining powerful visualization components and a data-driven approach to DOM manipulation. 2 other visualization libraries used are eCharts and MapV from Baidu. I believe that many of you have previously used the core statistical library eCharts. There are also many examples of this kind of map visualization in the version 3. MapV is an open source library for big data visualization. For this iClient development package, iServer also provides desired demonstration programs, where we can obtain the demo programs. If you have iServer installed locally, you can start iServer, input list address, click sample code at homepage to find demo program for the 4 products. If you do not have iServer locally installed, you can access the demo program from our official website, as we mentioned earlier. iClient for JavaScript is a client development toolkit for Cloud GIS. It's fully open source, and the source code can be downloaded from GitHub or OS Trainer. Okay, let's continue with the second part of this course, how to select the correct product from the entire iClient for JavaScript package that contains 4 products for different development models. Okay, now I will show you the comparison of the 4 products: iClient for OpenLayers, iClient for Leaflet, iClient for Mapbox.gl, and the classic JS library are respectively calculated based on Leaflet, OpenLayers 3 or 4, Mapbox.gl, and OpenLayers 2. What's the simplest reference factor for product selection? Lattice, where the product can provide rich examples. For open source products, it is judged through the star rating of the activity of the community. We know that Leaflet is the most active one in the open source community. Its highest star rating means that it is the most active and popular with the largest user base. It certainly has its advantage considering that so many people choose it. First of all, it is stable with relatively high performance, easy to extend, and the entire community's ecological chain is complete. What's more, it is also very convenient for code writing. Therefore, the user base for the products is large. As to iClient for OpenLayers, it is based on OpenLayers 3 or 4 with relatively lower activity of the community. Then, what are the reasons for choosing iClient for OpenLayers? We know that even through Leaflet is more convenient for presentation of data in latitude and longitude coordinates. Projection transformation is needed if the data is in projected coordinate systems. However, OpenLayers is convenient for the presentation of various types of geographic information data, which is one reason for selecting OpenLayers. Some users might choose the classic JS library for the old AC iServer based on the original OpenLayers 2 because the product's documentation is relatively complete, considering that it has existed for a relatively long period. Abundant samples have been accumulated and the price is now very stable after optimization for several versions. Through certain user base has been accumulated. The framework is a little bit out of date and with a presentation of the classic JS library for the old AC iServer is relatively weak. Currently, more and more users are now using the iClient for Mapbox.gl products, even through it has a disadvantage that it can only support the EPSG 3857 coordinate system for the basic data. Users of iClient for Mapbox GR are now accumulating. The rendering effects for MVT tiles are extremely good, and the effects are 3D stereoscopic display, and 3D are very attractive. What's more, it's convenient for code writing. From the above points, we can see that Leaflet has the highest score with rich plugins for choices. Anyway, we choose a product through comprehensive consideration of various factors. For example, the classic JS library for the old ACI server will be chosen because all developers have got familiar with the classic JS library due to the previous phase of the project. Where after introducing how to select map library, let's take a look at how to select the visualization library. First, we should look at a few pictures together. This is the presentation of the visual effect that Leaflet overlays with MapV. This one shows Mapbox GR with MapV. Still, this is the effect for combining Leaflet with eChart, and the migration effects simulated by Mapbox GR and eChart. We can see that the same effects can overlay with different base maps. Therefore, the choice of the visualization library is made based on the corresponding project list. We choose the visualization library that can satisfy the needs of our current project. We can take a look at the examples of visual effects of the sample programs, such as the samples for Leaflet below. These are samples for visualization effects of Mapbox GR. We choose the visualization library according to requirements. If interested, please go to choose the one with best visual effects. Okay, that's all for today. Thank you very much for your attending. See you in next call.
Hello everyone. Today I'll bring you to a quick start of Supermap iClient for JavaScript based on Leaflet in this course. I'll show you how to publish the GIS data via the internet and browse the service on the iClient. The target of this course is to publish a web GIS system that allows us to browse the published GIS data. So let's first take a look at the specific operation steps. First is to prepare the GIS data. Second, we need to publish the prepared GIS data. And the third is to develop the web system. And then finally, we will publish the developed system. Let's take a look at the first step, preparing the GIS data. The data should be produced by Supermap iDesktop. Here, we'll directly use the sample data from iServer. The China data. Well, then where's the data? We can find the data under the sample folder in iServer installation directory. As you can see, in the data folder, we can find the China data, the China workspace. When the data is ready, the second step is to create the iServer service. To create the service, we first need to determine the type of the service. Considering that we plan to achieve map browsing, we need to create a map service. And then we can start iServer. You may wonder, how can I start iServer? Well, there are two ways for you to choose. One way is to run the startup.bat file under the bin folder of iServer installation directory. Another way is to run Supermap iServer from the Start menu if you are using the setup package of iServer on Windows. When we start iServer, we can see the console showing the startup process. Finally, we'll see the startup time showing right here, which means we have started iServer successfully. Then we can enter iServer Web Manager for service publishing. If it's your first time to start iServer, you'll need to create an administrator account. When finished, we will be navigated to Web Manager, where we can use the shortcut command to quickly publish services. While publishing the service, we need to specify the path of the workspace and then select to publish the data as a map service. Okay, let's go through the specific operation process. Click on Manager, and then click Quickly Publish Services to publish a service for the sample data China. Select the data source as workspace, click Next, and specify the path for the data. Select REST Map Service. Click Next to finish the service publishing process. Well, we have published the China data. Click on the service address to enter the map list. We can then view the service through the leaflet representation style. If we can see the map, it means that we have published the data successfully. Here's the map. While developing the WebGIS system, the address of this map service specific to the map name will be used. Now we enter the third step, develop the WebGIS system. We will use the SDK included with Supermap iServer, which is Supermap iClient. The development tool packages are placed under the iClient folder in iServer installation directory. For system development, we first need to create the site for the system. We can create a folder called Getting Started. The folder will serve as the path for site publishing. Here's the folder. We can call it Getting Started. Then copy the script library files. We need to copy the dist folder under the for JavaScript folder in iClient. Here's the dist, and we need to move it to Getting Started. And the libs folder under web apps. Here's the lib. Well, the file's kind of big, so be patient. Considering that we're using Leaflet for development in this example, we need to include class libraries for Leaflet. Supermap allows you to include all related class libraries through the include method. Therefore, we need to modify the relative path of the include leaflet.js file and the libs folder. And here's the include leaflet.js file. And here we need to modify the relative path. Delete this and delete this. And also don't forget about the dist folder. You also need to delete the dots. Okay. When we're finished with modifying the reference path for the libs folder, click Save. Now, let's create an HTML page with text editor. Okay, here is the getting started. And then new index.html. And then open it with a text editor. And then you type HTML, the format. Okay, and here's a well-written basic page. We can save it into the created folder. Next, let's include the script libraries of Supermap. That is, include the modified include leaflet script file under the dist folder. So you do script. Let me delete that. Source equals to dist leaflet include leaflet.js. Okay. When finished, let's add a div control to place our map. Why should we create a new div control? To know the reason, we need to check the API for object instantiation. Considering that we're developing based on Leaflet framework, we can go to check Leaflet help documentation for map object instantiation. We navigate to map object and check the samples. Also, we can check the help document of Leaflet on Leaflet official website, or from the included path for Leaflet in Supermap iClient for Leaflet API. To instantiate a map object, a div control is needed. And we still need to specify the map configuration information, such as center point, scale, coordinate system, etc. Therefore, we first need to create a div control, set ID size for the div. Here's the width and height. Okay, that's our div. Generally, a map is loaded at initialization. A map is presented while the page is loaded. We can implement the onPageLoad function at initialization. Here's the function onPageLoad. Then, how can we initialize the map object? As we can see, to create a map object, we need to instantiate the map object of Leaflet, the div container, and the center point. We can directly copy the code of the sample from the help document. Here's the code. And it's my map. And the center point is determined according to the bounds of the loaded map. Okay, after we've configured the map container and instantiate the map object, we still need to add the service for the map object. Here I'll show you how to add the REST map service published by iServer. First, add an iServer layer to the current map and we can find the reference API in Leaflet API from JavaScript sample code on iServer homepage. Since we're going to load a REST map service for iServer, we first need to instantiate a tiled map layer object and add it to the map object. We can directly copy the sample code and add the layer to the map. Here, the URL is the service address for the map service, as mentioned earlier. Considering that we still need to call the map object in other functions, here we set it as a global variable. The service URL should be specified as the address of the map service published from the China data. And the URL should be specific to the map name. And here we copy that. You see my colon. Okay. We can click the map name to enter the page to check map information, such as map bounds, coordinate system, etc. As we can see, the coordinate system of the map is WGS 1984 coordinate system with the EPSG code 3857. We copy the address of the map with the center at 00. Okay, now let's take a look at how can we set the coordinate system for the leaflet map object. The map object has a map option property and the CRS of map option is EPSG 3857 by default. Considering that our data is also in WGS 1984 coordinate system with the EPSG code 3857, so we don't need to modify the CRS. Yeah, let's just put it here. Okay, here we have finished the configuration of the coordinate system. Still, there's one more point to which we need to pay attention. That is the center point of the map. For the map representation of leaflet, the center point must be specified with longitude and latitude no matter the data is in a projected or geographic coordinate system. To assist you to transform the coordinates of the center point, iServer offers a convenient way to allow you to transform the coordinates to the specified target coordinate system. For example, we can transform coordinates in EPSG 3857 to EPSG 4326. Considering that the data is in EPSG 3857, the values of the coordinates of the center point is in longitude and latitude. When finished the settings, we can check the page. Okay, let's open the index in Google Chrome. Yeah, the scale is a little bit too big for the current map. Here we can turn it to a smaller scale and check the effect again. Okay, here it is. Zoom in. Okay. Alright, let's move on to the last step. That is, to publish the web system through the web middleware. In this example, we're going to publish the web system with the Tomcat middleware included with iServer. We can directly copy the Getting Started folder to the Web Apps folder of iServer installation directory. Here's the Getting Started. Copy that to the Web Apps. Considering that the Getting Started folder is parallel to the folder of Web Apps, we can compose the URL by simulating the URL of the iServer service. Let's add the site name Getting Started after localhost :8090 and browse to check the effect. Okay, and here's the map. Alright, that's it all for today.
Hello everyone. Today, I will bring to you an overall introduction to SuperMap iServer. The course of today will be divided into the following sections. First, the positioning of SuperMap iServer will be introduced. Moreover, I will guide you through the capabilities of SuperMap iServer. Finally, you will learn something related to the product package. Okay, now, let's first take a look at the architecture diagram of the cloud and the client-integrated SuperMap GeoD. SuperMap GeoD contains a cloud GIS platform and a variety of development platforms that supports PC, mobile, and browser terminals. SuperMap GeoD fully supports the application of big data technology. Built based on the Java EE platform and SuperMap iObjects Java, SuperMap iServer is an enterprise GIS product with a service-oriented architecture. SuperMap iServer is a cloud GIS application product based on the cross-platform GIS kernel. It provides web clients with professional GIS functions similar to those offered by the desktop GIS product through services. SuperMap iServer allows us to manage, publish, and seamlessly aggregate multiple types of services, such as REST services, OGC services. Multiple types of client access is also supported. What's more, GIS functions such as data management, editing, and analysis in a distributed environment are supported. SuperMap iServer provides a service-oriented multiple-level extension development framework from client to server, which make it easier for application developers to quickly build Azure applications. Next, let's take a look at the users of SuperMap iServer. SuperMap iServer offers enterprise GIS application solutions, from development, configuration, deployment, to system publishing. SuperMap iServer targets different levels of users. First of all, GIS professionals can use SuperMap iServer to publish instant services, including publishing, editing, and sharing history data, publishing and sharing GIS functions such as a special query and analysis aggregating services, published by other GIS professionals, and so on. An application developer can build an application system using the web service interfaces published by GIS professionals. Since SuperMap iServer also provides a complete set of SDKs, application developer can use the server-side interfaces provided by SuperMap iServer to develop applications. What's more, application developers can extend SuperMap iServer SDK according to business needs to better integrate with business systems. Non-professionals can apply this iServer web services published by professional to daily business system. In addition, system administrator can perform remote configuration management and service published through SuperMap iServer Work Manager. They can remotely publish GIS services, manage log services, configure clusters, and so on. All this assists in forming a complete and seamless business workflow. Okay, let's move on. You may want to know the capabilities of SuperMap iServer. The capabilities of SuperMap iServer mainly focus enterprise-level JS server, and service JS development platform. First, SuperMap iServer is a cross-platform enterprise-level JS application server that provides a complete set of JS services to meet different needs of users. For example, if the current user wants to perform a basic browsing operation of the map, we can publish a map service by iServer. The GeoD series of products also support new workspace and data sources, including PostgreSQL workspace and MongoDB data source. Moreover, the new version supports publishing vector tiles in Mapbox MVT format as services. If the user wants to access and edit the data, we can choose to publish the data as a data service. SuperMap iServer can also publish services to allow spatial analysis, traffic level analysis, and traffic transfer analysis on the client side. SuperMap iServer has added support for the geometry service, which allows the client to measure area, measure distance, convert coordinates, and so forth, without publishing map and data services. SuperMap iServer also supports the publishing of three-dimensional scene data for data browsing. What's more, network analysis service is also supported. SuperMap iServer GeoD also added support for the REST.js matching service, which allows the clients to acquire coordinates through the keyword of the address or gain the address through coordinates. As mentioned earlier, SuperMap iServer currently supports big data JS applications. Now, let us have a look at the supporting services for big data. The supporting services contain the distributed JS service, data catalog service, real-time data service, and data stream service. Okay, now let's go into details of the four supporting services. The first one is distributed JS services. The distributed map visualization is mapping with the appreciation of multiple rows of distributed cluster of Spark. It supports the output of map result in MongoDB, and the results can be automatically published as map and data services. The distributed analysis is also based on the Spark distributed cluster. Multiple rows properties in the analysis functions, such as density analysis, aggregation analysis, overlay analysis, buffer analysis, and so on, to increase the analysis efficiency. SuperMap has also added a data store, SuperMap iServer data store, to construct a catalog service for the data. SuperMap catalog service provides a convenient data organization and management method. The catalog service allows the unified management of the data hosted by SuperMap iServer, and the user manager. Multiple iServer data stores are supported, and therefore thousands of relational database, spatial temporary data, etc. are supported. What's more, an entry has provided to ordinary users for viewing and retrieving various types of data, including relational data, binary data, big data sharing files, tile data, spatial temporal data, and more. SuperMap iServer also provides the real-time data service for analysis and processing of real-time data in CSV, JSON, and JSON formats. Currently supported data access protocol including WebSocket protocol, HTTP protocol, TCP protocol, and Kafka communication protocol. Okay, now let's move on to the final supporting service, the data stream service. The data stream service supports real-time data transformation, which is a server propagation and a client substitution function provided based on the WebSocket communication to achieve real-time data transformation between the server and the client. SuperMap also offers capabilities of aggregating services and constructing clusters with SuperMap iServer Work Manager. SuperMap iServer Work Manager also allows us to cut tiles in a distributed environment, monitor services, configuration the multiple process mode, and more. Okay, now let's take a look at another important capability of SuperMap iServer. Another important capability of SuperMap iServer is the diverse development APIs offered. SuperMap iServer provides the client GIS application development toolkit, SuperMap iClient. SuperMap iClient contains packages for 2D and 3D application development that support Word and mobile terminals, such as the JavaScript development framework for both mobile and Word terminals, the Flash framework for 2D web application development, 3D non-plugin WebGL, and the 3D plugin development framework. SuperMap also provides packages that support native development for platforms including Android and iOS. What's more, designed and implemented complying with the server-oriented architecture, SuperMap iServer also serves as a GIS service development platform that allows the extensions of each model in the architecture by providing a complete set of SDK. The service extension capability of SuperMap iServer assists secondary development users in extension development for integration with their own business systems. Well, before the ending of this course, I still want to introduce something about the product packages. SuperMap iServer provides various types of product packages, including the install version, the green version, the VAR package, the middleware deploy package, and the deploy package for the server. We can choose the appropriate package according to the requirement. For example, the development phase and the deployment phase have different requirements on the packages. Okay, that's all for today's course. Thank you very much for your attending. See you next time.